in this problem, you have all this information and then the actual question, which is to find the magnitude of the normal force exerted on the car by the walls of the cylinder at point A, which is the bottom of the car. So you can tell this from real life, which is when you're on a roller coaster, you're going to feel more weight on you here than on here. That's because since you're completely on the almost on the ground at this one instance, all your weight is going to be pushing down on the roller coaster, and the roller coaster is going to be pushing back up. Because if it didn't, you just fall. Here though, you can see that since it's upside down, like very minimal amount of the actual car is touching it's still touching the top of the circle. But the thing is, most of the weight is being pulled down by gravity, so you're going to feel a lot less normal force on you because gravity is going to be pulling down, and the normal force is actually going to be pointing down. But it'll be since you'll feel so much less normal force, you'll feel the sensation of weightlessness, but it doesn't mean you lost weight. So the first thing you can do for a physics problem is just draw a free body diagram. So you draw all the forces that are acting on this. So you know that gravity is always pulling down on the object, and then since it's on this and it's not falling down, you know that the normal force has to be in the opposite direction. And what you can also take into account is, this isn't part of the free body diagram, but I just drew it. What direction is the acceleration? Well, the acceleration's inward, so it's going to be pointing up. And then I drew the y and x axis to show you that, so since it's pointing up, this would be positive, this is pointing down, this is the negative part of the y axis, and this is pointing up, so it'll be the positive part, so this will be positive. So now the actual question, what is the normal force? So we need to find out what this is. So with a lot of problems you can do this method, which is you just set up the x force and the y force, and it'll be the sum of the forces is equal to ma. So all I'm doing is I'm adding up all the forces and then setting it equal to ma, which is Newton's second law. So in the x direction we sum up all the forces, but we look at it and there's actually no forces in the x direction. This is in the free body diagram, but this will be important. So there's nothing in the x direction, so we actually don't even have to worry about it for this problem. So next problem, Fy. Okay, so I just said that this part is going to be positive because it's the positive part of the y-axis. So this will be positive, Fn, minus Fg. So gravity is negative, and that's what makes this negative. Because mass can't be, because gravity is, the force of Fg is mass times gravity. But gravity is actually the one that's going to be negative in this case. Therefore, the entire thing becomes negative. Because if mass is positive and gravity is negative, then the entire force would be negative. And that's equal to ma. And then in this case, see, like mass is always positive. But you look at acceleration, and since acceleration is pointing up, then that means acceleration will also be positive. Now you just plug in anything you know. So we know Fg because in the problem we are given mass 1.61 kilograms, and we know what gravity is, so we just multiply by 9.8. So all I did was 1.6 times 9.8. I got this, and then I still have Fn minus this is equal to mass, once again, 1.61. And then acceleration, remember, is not just like velocity divided by time. It's actually, since it's a circle, it's going to be uniform circular motion. So you're actually going to use this formula, v squared over r. And they actually do give you this information, which is right here. You have v and you have r. So you go back to the problem, and then that's all I did. I just plugged in those numbers. For velocity, I plugged in 12. For radius, I plugged in 5. And then I multiplied all those out, and then I got 46.368. And then for each side, I'm just going to cancel out units. So here, I just added it. and then I got 62.146. That will equal our newtons. But remember to always check for this. You have to check if it's going to be positive. So if it's a force, and force is really direction, not positive or negative. And also, since it's magnitude, we already predicted that it would be positive. Since everything here is in 3 sig figs, this one's going to be 3 sig figs. And finally, since it's a force, it will be in newtons. So, yeah, that's it. And the base thing to physics problems is just the setup. So just remember to draw a free body diagram. Take into account like what, if it's a vector, take into account if it's positive or negative, because this one was. And remember, when you're setting up right here, just remember that you have to consider which one's positive and which one's negative. This one was negative because of gravity and because it's on the negative y-axis. I hope that helped, and thanks for watching.